Hey guys, welcome back. We got a fresh new week here, our first full week of school, which I am incredibly excited about, at least for our in person students. For some of you virtual learners, it's going to be kind of business as usual, but we are on our way towards the end of this chapter. That means that within a week or so, we could be seeing our first test, guys. So just kind of keep that in mind as we're working through. I don't want to say that to cause you panic, but I want you to be thinking, okay, is there something where I have some gaps in my knowledge that I need to be asking Mr. Harris about? Also, on Tuesdays and Thursdays, if you guys, especially my physical learners, but even my virtual learners, have time, if you can schedule ahead of time, I don't care at all to meet with you to work on tutoring and just to get you guys ready and help you in any way that I can. Because that's what this is all about, guys. I want to help you to succeed and grow in intelligence and just become more confident learners and just not be afraid of math. But I'll hop off my soapbox. We're 1 minute in now. But on Friday, we had a chance to introduce day one, which just saw us dive into some pretty complex multi-step equations. And I would really strongly encourage you to revisit day six and the first part of day seven, too, as we're going through this week. Just as a reminder and a refresher, I would also really encourage you to look over the homework that is posted under chapter one, resources. I have all of that homework there blank, and I have all the answer keys there too if you want to check yourself to make sure you're learning and on the right track. But guys, let's get into part two on the back page of day seven. Now, not nearly as many problems on the back page, only actually 8, but they're a little bit more intricate in that we kind of have to think a little bit about what it's asking. And so the first two problems may look a little scary, but they're actually asking pretty straightforward questions. Let's look at this one. Let's suppose we wanted to solve this multi-step equation right here. It's actually 3 steps. What would you do, though, as your first step? And then we just got to explain. And that's all it's asking for, guys. What do you think we should do for our first step? I'm thinking we need to combine our variables that are like terms. If you don't have parentheses, look to combine variables. Now, if that 7x had a square above it, we obviously couldn't do that because 6x and 7x squared wouldn't be like terms. But that's 6x, that's 7x. We are combining our variables. And we're doing that through addition. 6x and 7x would give us 13x. And so if you wanted to, you would have 13x plus 3 on the right side. That plus 3 is still showing there. And then negative 5 on the left side. And they only ask us for the first step. But I know you guys are strong learners, so you're probably already thinking, okay, then I could subtract that 3 over to negative 5 to combine my numbers and then divide by 13. But we don't have to do that. Just wanted to let you guys flex, though, to know you got it right. How about I'm going to pause and see what you guys think we should do just for our first step on number 2. If you said that 8y minus 12 can't be combined, but we can distribute that 1/4 to both 8y and negative 12, then pat yourself on the back. You're a genius. Distribute 1/4. And so that would look like negative 10 on the left still equals, well, what's 1/4 of 8? Well, you take 8, multiply it to the top of 1. 8 times 1 is 8, and then 8 over 4. Oh, 8 divided by 4 is 2, but don't forget there's a y attached to that. Minus, what's 1/4 times negative 12? Well, 1/4 of 12, you take 12, multiply it to 1. 12 divided by 4 gives you 3. So that would be our first step there. Now, these next 2 questions, guys, I'm not going to lie, they're a little bit tougher. This, especially number 3. Number 3 is going to be our challenge problem of the day. So we're told the sum of 3 integers is 228. By the way, guys, integers, these are just whole numbers. Now, they could be positive, they could be negative, but they are just whole numbers. So if you add up 3 numbers, they give us 228. But here's the problem. They don't tell us any of the numbers. Instead, they tell us that the second number is one more than the first. The third number is two more than the first. Okay, let's think about this. If we don't know any of these three numbers, what do you guys want to call our first number? I'm not going to call it X, that's boring. Let's go C. So C, I wonder why I chose that one. C is our first number. Now, what are we told about the second number? It's one more than the first. So if C is our first number, we know these numbers are all going to be added up to be 228. Then what could we represent our second number by? Well, C plus 1. The second integer is one more than the first, so you take your first, add 1, now you got your second term. How about the third integer? The third integer is 2 more than the first. So plus, because again we're adding all three numbers, we take C and we add 2 to it. So here's your first number, here's your second number, and here's your third number. And guys, all of these add up to be 228. Now you're probably thinking, whoa, why'd you put parentheses? You don't have to. I just wanted to show you how these were split up 1, 2, and 3 as far as these three numbers are concerned. You can drop the parentheses. And by dropping those parentheses, that then lets us combine like terms. 1C plus 1C plus 1C, they're all on the left side of the equal sign. We can smash them together. That gives us 3C. And then how about 1 and positive 2? Combine those together. That's 3 equals 228. And now we've got ourselves a two-step problem. Subtract 3, 225, and then divide by 3. And C is going to equal 75. Now, remember, that's our first number. We just found what C was, our first number. What does that mean our second number and third number are going to be? Well, the second number is one more than the first. So our second number is 76, which means our third number, which is one more than our second number, is going to be 77. And we've got our three numbers, guys, that add up to be 228. And that one was kind of tricky, but when you look back at that problem, you think, oh, that actually maybe hopefully makes sense. Last problem, guys, before I turn you loose. This one's also an interesting one. I want to play golf someday with my dad. It's one of the few things I think he'll be able to do when he retires, but I'm definitely not good enough to be playing yet. But we got 4 friends here. If you do play golf, shouts out to you because it is the toughest game I've ever played. Now, we're told 2 of them need to rent clubs at $5 per set. So 2 of them are renting clubs. Now, the cart rental for just all 4 friends, they're all going to be riding this for just one payment of $10. Now, the total cost was $92. So what we're going to do is we're going to represent the total cost of the golf outing per player. And guess what? That's our variable right there. We're trying to write an equation to represent the golf outing per player. So I'll go G since we're talking golf. This is price per player. Remember, when we solve a word problem, we got 3 steps. Step 1, read one of the last sentences to find your variable. Step 2, see if they give us a total. And by golly, they do. They paid a total of $92. Now, step 3, add in your variable as well as the other numbers. So we were told straight up that two of these people bought $5 sets of clubs, or rented, which is really, really cheap. So really, you've got 2 times 5 here. 2 kids or 2 friends rented $5 clubs. Plus, cart rental was $10. Now, here's the tricky part. We got to find a way to put our variable in. It's not just going to be plus G. G represents the price per one player. Well, how many players do we got? That's right, we got 4. So plus 4G. I know we're living in a 5G world, but we're talking 4G here. And so now we've got the setup. All of this is going to add up to be that $92, including the green fees. So guys, I'm going to pause the video, and you can go ahead and pause it and see if you can work this out for G. Go ahead. Okay. So when we work this out, we combine 10 and 10 to get 20, subtract 20 over to get 72, and then divide by 4. So it was $18 per player. So nice work there, guys. And as far as the green fees go, we know that that for 4 players to play, that added up to $72. That means that to get to that 92 total dollars, we had to pay $20 worth of fees added on to just how much it was to play. So with that in mind, I'm going to turn you guys loose on some homework here. I know a short lesson to start off the week. Hopefully you guys like that. But I need you to be very, very careful. And especially on these first 3, you're probably going to want to do these on a separate sheet of paper. These first 3, I would work out. Let me rephrase that. Work out on a separate sheet of paper. Yeah, especially these 3 right here. Now, number 4, this is going to be kind of like number 3 up here, except a lot simpler. We're going to be putting together an equation based off the words and then solving. So, best of luck there, guys, on 1 through 4. We'll check these tomorrow. Come in ready to have them checked. We may do an activity based off of. If you have any questions at all, please feel free to let me know, and I'll be talking to you guys soon.